Hello and welcome to another episode of Risky Business. Today, we are going to continue investigating this little mystery we had from the last episode. If you go here to Milton, you'll see that we're not rendering lines, and when we toggle the line visibility, that's working, as you can see in my printout. And we looked into it and we saw that all this code is actually running. So we are actually rendering lines, but they're not being presented to the screen. And when I move the canvas, the lines are presented to the screen. So today I think what we're going to do is work backwards and see what's going on here. So I'm going to go... Well, first of all, let's see where main is. So we have a Milton main in stlmilton.cc. And the actual main is in platformunix.cc. So let's start with platformunix.cc. Alright, so the actual main is just calling GTK init, and then it's running the Milton main. So let's go over to stlmilton.cc and take a look at Milton main. And we are going to look at this from the bottom up. So let's see here. So here it looks like we are out of the main loop and we're cleaning up before we close. So I'm guessing this scope right here is the main loop. Yep. So let's see what we're doing in here. Here we're sleeping at the end of the frame. IAM-GUI events might update until the frame after they are created. Might update until the frame after they are created. I'm guessing he means might not update until the frame after they are created. So let's see here. Update and render. So let's see what we're doing here. Pushing onto the profile graph, we don't care about that. So it calls Milton update and render with Milton state and Milton input. And then if the Milton state is not running, it sets it to should quit. So then it does IAM-GUI render and GL finish, and then STL-GL swap window. So first of all, let's take a look at STL-GL swap window and GL finish. So STL docs. So we are looking for a swap window. So this is used with double buffered OpenGL contexts, which are the default. And it doesn't really say anything other than it uses this function to update a window with OpenGL rendering. So this is just presenting the stuff we've rendered in GL to the actual window. And then before we do that, we do a GL finish. So let's take a look at that. Okay, so GL finish is just a call that blocks until all GL execution is complete. So we wait until we're done rendering, and then we flip it onto the screen with the SDL GL swap window. And when we actually render, we're doing all that in Milton update and render. So we're probably going to want to take a look at Milton update and render. First, I want to just kind of, just browse through the code before that point too. Because what we're looking for is something that would cause the behavior that we see in Milton. So it's got to be, if we toggle lines and then we move the canvas, that suggests that there's something that's caching what we rendered before we turned on the lines. And even though we're re-rendering everything, we're actually flipping onto the screen whatever it is we've cached. And then when we do a movement, that's actually setting the cache to dirty. So it needs to take what we're rendering and use that instead. That is my theory of what's going on. So we're trying to find where that's happening. So what are we doing up here is the question. So I'm just going to scroll up a ways and then start reading down. So here's the main loop. It says while should not quit. It gets a perf counter for the frame start. Does some IOM GUI stuff. It runs the SDL event loop to get Milton input. Here's some stuff that's commented out. It does a panning update. Okay, well that's interesting. A panning update sticks out to me because it's when we pan that it updates and we see our lines. So we might actually want to take a look at the panning update. But let's keep looking through here. If we're not panning, it sets hovering, and hover point is the platform state pointer, so that would just be where the mouse is. And then we have first run, so here's some stuff that just happens on the first pass. And all that we're doing there is we're saying we want to do a full refresh. So let's see, SDL get mouse state for the X and Y, and then we're handling the system cursor and platform state related to current mode. So if we're panning or if we're waiting for pan input, cursor set and show. If we're exporting, oh okay, so cursor set and show sets the cursor. So this is cursor size all, there's cursor crosshair, cursor default. So these are just setting the crosshair depending on what's happening. So like here's if the GUI is visible. Yeah, so all this stuff is just for the cursor. So if we're in Milton mode pen or eraser, we hide the platform cursor because we're showing our icon instead. So here we're showing the icon that I just mentioned. So here's something specific to OS X, but we're on Linux, so we don't care about that. So input flags is Milton input.flags. What are we doing with those? So we're doing some IMGUI stuff. So this has to do with when we capture a widget. And then it does an IMGUI tick. So here's some stuff if we're zooming. So what else do we have? Num pressure. That would be like for a drawing tablet. Okay, what are we doing here? So here we're forcing a full re-render. Interesting. And there's a to-do here that says remove use of Milton input flags, full refresh after switching to hardware rendering. We're using hardware rendering, so this is out of date. But this is interesting. This code path catches my eye here because we're setting a full refresh flag and a request quality redraw. And this has to do with panning. So it's saying if pan delta x is not 0 or pan delta y is not 0, or if we've resized the screen, then it does a Milton resize in pan, and it says if not pan OK. So I'm not sure what that means when Milton resize in pan returns not pan OK. But if it does, it requests a full refresh, which may or may not be relevant to us because of this comment. It's suggesting that it's no longer relevant. It was something for software rendering when we were doing software rendering instead of hardware rendering. And then we get to the point where we do the update and render. So I think before we take a look at update and render, there was that other thing higher up that caught my eye. What was that? Panning update. So I want to take a look at what panning update is doing. So I'm going to search for panning update. And that is defined in stlmilton.cc, which is what we're in. So it said it was line 56. So this is it looks like we're just setting some flags here. So if platform state waiting for pan input and pointer is down, we say waiting for pan input is false, is panning is true, reset pan start. If space is down, we cancel, so we say waiting for pan input is false. If we're panning, so that setting is panning to false. This is setting pan point to wherever the cursor is. And then what else do we have? So if space is down and the pointer is down, or the middle button is down, we say panning is true and we do reset pan start again. So there's not a whole lot of interesting stuff going on in that other than reset pan start. So we might want to take a look at reset pan start. So it looks like reset pan start is defined in stdmilton.cc, and apparently it's actually a C++11 lambda. So let's search reset pan. Okay, yeah, so that was right at the top of the panning update. I guess I skimmed right over that. So it captures the platform state, and it says pan start is pointer, and pan point is pan start. So it's just setting both of these to be where the cursor is for the beginning of the pan. So yeah, that's not what we're looking for. So what else was there? So we know it's definitely not the panning update function. There was one other point that was, I don't know, a little bit suspicious to me, I guess you could say. Where was that? So here's the panning update. And then if we go down, here's all the cursor stuff. We don't care about that. Yeah, it was this part of the code right here that I was looking at. So there's this Milton resize and pan function. And we said if not pan OK, then do a full refresh. So I'm interested to see if maybe that code path is getting taken when this happens. So I'm going to do a printf here just to test if this is the code path that's doing that, because it might be that when we do the update and render, it's this full refresh flag or the request quality redraw flag. One of those that might be actually doing the flip that we want to have happen. So I just want to check if this code path is getting taken in the case that I'm thinking it might be. Oh, I'm still printing the flags. Where am I doing that? Hardware render.cc. Okay, so now we're not printing the flags. Now if I move the canvas, we don't see that. What happens if I toggle line visibility and then move the canvas? We don't see that print, so that is not the case. So that answers one of our questions. So then it has to be something going on in the Milton update and render part. So let's take a look at that next. So that is defined in milton.cc. And we are looking for update and render. So I don't know, should we read this backwards or should we read it forwards? I think I'm gonna read it backwards. So we do GPU render at the very end. So we might want to take a look at that. There's the GPU clip strokes and update. I don't think that's relevant. I mean, maybe it is. We could take a look at it later, but I don't think so. Here's a if do full redraw. So this sets the view width, view height, and clip flags. And those get passed into the GPU clip strokes and update. The width and height also gets passed into GPU render, but not the clip flags. Okay, and there's a code path here that's if redraw every frame. Then it says do full redraw equals true. What's the config? Or, whoops, I wanted to ls there. So I know there's like a Milton config file. Yeah, Milton configuration.h. Jedarma, if you go to risc-v and watch the trailer, you'll get a overview of what the series is about. And specifically what we're doing right now is we're working on this drawing program. So there's a thing in the chat to explain it. So that is what this project is about. So we want to go to Milton configuration.h and we want to see if we're redrawing every frame or not. So we have redraw every frame set to 0. Let's set it to 1 and see what happens. So now if I do view, line paper, grid paper, yeah, so when we have the when we have redraw every frame set, it does update immediately like we want. But we don't need to redraw every frame. We just need to see what code path it's taking when that's happening, and then do that when we do the paper, or when we do the toggle, I mean. So let's search for redraw every frame. So yeah, it's just that one code path that we were looking at. So if redraw every frame, do full redraw equals true. And then if we're doing a full redraw, the difference is that view width is set to Milton states. So view width and height are set to the screen width and height. And then clip flags is set to clip flags update GPU data. So what we want to do is make sure the do full redraw path gets taken in the case where we've toggled the paper mode. So do full redraw is a local variable to this function. So we need to, somewhere in this function, we need to set it to true. So there is a input flag, Milton input flags full refresh. So I believe we could set that, and that would be sufficient. And so the reason it happens when we pan is because this case right here, it says if input flags has Milton input flags panning set, then it does this full redraw. So I'm going to force it to take this path right here when Milton input flags full refresh is set. So first of all, let me see where input is defined. Okay, so we're passing input into this. I'm just wondering where I can set the proper flag. It's not a Milton state flag, so I need to actually pass the Milton input into my my toggles. So first of all, let's turn off the redraw reframe. Now I want to search toggle and see where we're actually calling that. So let's narrow it to toggle visibility. Okay, so prototypes in GUI.h, defined in GUI.cc. It looks like we called them as well in GUI.cc. As well as Milton.cc and SDLMilton.cc. So first of all, let's go to GUI.h and update our prototypes. So this needs to take Milton input. Or not the GUI one, the line one and the grid one. And then we need to go to GUI.cc and update the implementations. And now at the end of this, we're going to say input flags, and we're going to turn on the Milton input flags full refresh. So I think that looks good. Now we just need to update the call sites. So we call it here. And do we have input here? So it looks like we do. Up here we see we have an input. So I think we can just pass in input or not the GUI, just the line and grid. And where else? So Milton.cc, those are just GUI. SDLMilton.cc is the other place. So let's head over to SDLMilton.cc. And here we are. Now, do we have input wherever this is being called? So we have input flags. I think we're building the input in this code path here, because this is the event loop. So this is taking a Milton state and a platform state, and it has this input flags. So I wonder if maybe we should be passing input flags in rather than the Milton input structure. So here we're talking about a Milton input though. Where did we define that? Oh, okay, so yeah, here's our Milton input, and we started out just being a empty zeroed out struct. And we're filling that out as we go. So really what we care about is input flags, because presumably we update or we store the input flags in Milton input at the end, and then store Milton input in one of those, probably the platform or something that we passed in. Okay, yeah, we're returning Milton input. So we set Milton input.flags equals input flags at the very end, and then we return Milton input. So actually, rather than taking the entire Milton input, we should just take the input flags, because we need to do this when the Milton input is kind of half-baked. So we're going to go to GUI.cc, and we're going to update these so that it takes an I32 called input flags. Or, well, no, because we need to pass it out as well. So I guess we take a pointer to an int, right? So we do it like this. We take a pointer to our input flags, and then we dereference it and set full refresh. And then for this, I pass it input flags, and we'd want to pass the address of that. And then we want to update the signatures in GUI.h. And then back to sdlmilton.cc. So here we pass input flags in. Like so. And with that, I think we should be good. So let's try toggling again. So yeah, that's working correctly. So we can cross out fixed delayed update from our... Did I reboot since... Why did that draw in the wrong place? Yeah, I haven't done the X input thing. So with this tablet, by default, it maps my tablet screen to both of my my monitors, because I have two monitors and then the monitor on the tablet. So I need to map it to the proper output. And now it is mapping properly. So I will cross out fixed delayed mode update. And now the only bug that we need to, well, there's two things. First of all, it should have started by default in line mode. So we need to get it to default to line mode. And then we need to fix the bug when drawing or erasing lines, which you can see there. And that's probably going to have something to do with the same pipeline that we just looked at, because you see that when I draw it, right, it gets this problem, but when I pan, it does the full refresh, and that fixes it. So I don't know, like, I mean, the problem is that when we're drawing or erasing, that happens in the first place. But one hacky solution is, rather than making it so it doesn't do that in the first place, we can just force a full refresh while we're drawing the line or something like that, right? But before we do that, we're going to make it so it defaults to line mode. So let me see here. So we have these Milton paper flags that we're using. And I thought we already did this. So apparently we did it in the wrong place or something. So I'm going to search Milton paper flags and see what all we have. So it looks like it was in milton.cc that we did this. So let's go to milton.cc. So yeah, you can see right here that we're saying paper init, and we set the paper flags to be paper visible and line mode. So the question is, why is that getting overridden when we're doing our init? So this is in Milton reset canvas and set default. So let's go back to the Milton main. And see how the init is done, because it's probably not calling that function. So here we set up our Milton state, and there's a Milton init function. Which is defined in milton.cc. So let's head back to milton.cc and paper init. And then we're going to go to Milton init. So here's the GUI init. So I'm going to paste in my paper init right there. Now, when we start Milton, we start in paper mode. So perfect. Now, the only thing we need to do is fix the bug when drawing or erasing lines. So, first of all, we need to figure out what is happening when we're drawing lines, or erasing lines, for that matter. So I want to go back to the stuff about full refresh. So there was something in this main loop about doing a full refresh. Maybe it wasn't here. I've already forgot it. It was probably in the Milton update and render. So where is Milton update and render? So that's in milton.cc. Yeah, so do full redraw. I want to see the cases where that gets set again. So my solution is just to do a full redraw when we're having the problem, rather than trying to actually fix the underlying problem. Because, you know, this is just a hacky fork for the stream. So the question is, we need to start studying the code to understand what's happening when we're drawing and when we're erasing. So here's a comment that says end stroke. What else do we have? So there's undo redo. So right now we're just reading the code to get an understanding of what's going on here. So set the hover point as the last point of the working stroke. So here's a Milton stroke input. And this is if we grabbed a slider. eyedropper. So I think the end stroke code path is what we care about, probably. So I kind of want to just throw in a thing here that just is like do full redraw and see what happens. Okay, now I'm going to try drawing again. And we see the problem. And it goes away when I end the stroke. Now, here's an else that says if user is drawing. So let's try it in here and then comment this one out temporarily and see what behavior that gives. Okay, so now it works when we're drawing, but it messes up when we end the stroke. So we simply want both of them. And voila, problem solved. So we have finished everything on our feature list. I'm happy with what we've got. So as of today, I believe we are done working with Milton. And I guess the next episode we will be jumping into risc-v related content. Or maybe we'll do like a celebration stream before that or something. But yeah, so that's a pretty exciting milestone that we just hit today. And that will be everything for today. So thank you everyone who tuned in today. And thank you everyone who watches on the YouTube archive at risky.tv. You can follow me at HMN_risky on Twitter to get updates about the series. And I will see you next time. Stay risky, everyone.